So if this is all H. Hi, I'm George Crump, lead analyst with Storage Switzerland. This is part of an ongoing series of Chalk Talk videos that we're doing on items of interest to the storage community. In this video, we're going to continue to focus in on the storage hypervisor and how to add solid state to that. One of the challenges with adding solid state storage appliances to the storage hypervisor is how do you maintain a high availability. Many of these systems are highly densely packed, small footprint devices that tend to not have some of the enterprise availability that we expect in enterprise class hard drive based systems. And most typically where you'll see this weakness is in the backplane itself. While there often will be dual controllers and some sort of RAID or data protection on the device itself, the memory backplane where the boards are inserted into typically can be a single point of failure. And so as a result, if that goes bad, you've lost access to all your data. And obviously in a virtual environment, that's not a very good thing. In fact, it's probably not a good thing in most environments. So while the chances of a backplane failure are relatively low, the fact that it can happen and the consequences, if it did happen, are so great that we need to work around that. So what you would typically do is buy two of these systems. The problem is that while in single application environments, like for example in Oracle or a particular operating system, there tends to be a mirroring function built in where you could set it up so anything written to device A is also written to device B. Those type of capabilities don't exist in most hypervisors, at least not yet today. So we actually need the availability built in. Of course, the other big challenge is that you have to actually buy two boxes. And again, solid state, despite the price decreases, is still a premium price technology. So you'd rather not have to buy two if you didn't have to. Now, what we're starting to see is the capability in these multi-application environments to be able to start to see high availability options where we have dual backplanes, dual controllers, and everything is highly available so that we don't have to worry about data loss. With that kind of capability in effect, now we can bring in an appliance focused solely on performance, move our most active virtual machines from hard drive storage to solid state storage, not have to do anything fancy like replication or mirroring or anything like that because we have basically enterprise class availability now, and then be able to service those up to our hosts as fast as they possibly can take it. And again, leveraging the technology in the storage hypervisor, we can migrate data back and forth between the two systems as particular VMs get hot or not hot. So what that means is we can keep the investment in what we need in solid state relatively low and put most of our less frequently accessed virtual machines right here on the hard drive system. What this also brings then is the ability to keep the data services that the solid state storage system provides, what we would describe as relatively thin. So we don't want to slow this high performance system up by having to have it manage thin provisioning and snapshots and replication, all these different things. That actually can be done quite well now by the host itself, the data services that come with the storage hypervisor or through third-party software applications. And then have them manage it all host side and allow the solid-state storage device to really focus on delivering high-performance storage. So the result is you get the best of both worlds. So let's dive in deeper to what high availability would look like in a solid-state storage appliance. So what we expect to see, companies like Texas Memory are doing this sort of technology, where there are a series of boards that have flash memory installed on them. We have a two back planes that they connect to, and then we have dual controllers that connect out to the storage infrastructure. What's interesting about this type of technology, for example, what Texas Memory is doing, is they now have the ability to have RAID protection on the board itself, and then they have RAID protection across the board, so data is written across the boards, and then you also have the protection of the dual backplane. So what you end up with is really 3 times the protection. It's sort of like if we had disk drives in this storage controller and we had some sort of data protection on the disk drive itself in addition to RAID 5. So we've got data protection now happening on the board itself. We have a RAID-like data protection happening across the boards. And then we have the redundant backplanes, redundant controllers. So well beyond no single point of failure, and very, very, very viable to be able to place virtual machines on. This type of technology suddenly becomes a perfect complement for the storage hypervisor and the virtualized world, which is full of this mixed application, mixed deployment model. A really good strategy for going forward. In 2012, storage budgets are expected to be relatively flat. So going in and replacing an entire storage system in that environment may be very difficult to do. Adding one medium-sized solid-state storage device, offloading your virtual machines to that transparently, because it has all the high availability, will give you the best of both worlds. High performance without a huge investment, and continue to maximize your investment in hard drive storage down here. You may end up with solving your performance problem and getting an additional 3 to 4 years out of your existing hard drive system. That is a good strategy, especially in 2012. Again, I'm George Crump, lead analyst with Storage Switzerland. Thank you very much for tuning in today.